We are doing exam revision of linear algebra, and in particular, in our first question, we're going to show that a set of vectors with a specific property is a linear space. Now, recall from my video on linear algebra and specific linear spaces, they will give you the set of vectors in a certain space, but with a certain property, and then you have to show that that set is a linear space over the complex system. So here we have that the vector x is in C3. Remember, C3 is like R3. It's our three-dimensional complex space. So in other words, we have a vector with the three components, the x, y, and z component, but here they can be complex numbers. Now the property that is given is that the 3 by 3 matrix times the vector x transpose is 0. So remember, they will always give you a set of vectors with a specific property. Now recall what I said you must always do in the first two steps. You're gonna let x1 be in C3 with that specific property. So in this case, such that AX1 transpose is 0. So you're going to choose two vectors in C3. So the other one is x2 in C3, such that x2 transpose is 0. So that is very important. Remember what I said, that you choose these two vectors with a specific property. Now, what you're going to do, we're going to write x3 as a linear combination of the two vectors that we've chosen, and hence the reason why we need to choose two vectors in C3. Just recall, a linear combination is when we times both our vectors by scalar multiples and we add them. That's a linear combination. So just make sure that you remember here that these two will be scalars. So now what do we have to show? We have to show that our linear combination is again in x3 and that it has this property. Hence, I must show that x3 in C3 does have this property. So that's what I need to show. Now remember what I said you're always going to do. You are going to use this. Very important. That's why you have written this down. Now what we're going to do is we are going to start with this side, and what must we end up getting? We must get 0 at the end. So what I want you to remember here, start on your left hand side, x3 transpose. What do we see we have here? Now remember what I've just said, you have your 3 by 3 matrix. What do you have here? If x3 is a linear combination of x1 and x2, x3 transpose will be the linear combination of x1 and xt transpose. Now, what I also want you to remember, what's very important from first year, please study your properties, especially for linear spaces for the exams. So the one that we're going to use in particular now is the transpose of the sum of two matrices. It is in fact the transpose of A plus the transpose of B, and so with the difference. And what you're also going to use later, the constant scalar A transpose is just scalar times A transpose. Then very important, AB transpose is B transpose A transpose. I also want you to study for the exams. It could come up in your exam on linear spaces as well. I want you also to study the properties for determinants, which you have done in first year. So back to this question. So we've just said that if we have two vectors transpose, we can split and separate them and take the transpose of each one separate. So we have the A on the outside, we have alpha 1 x1 transpose plus alpha 2 x2 transpose. But what did we just say from our properties? Alpha 1 x1 transpose. Remember, you can't transpose a scalar, hence you just leave it as alpha 1. And then you have x1 transpose. The same here, x2 transpose, scalar transpose just says the scalar, x2 transpose is x2 transpose. And just recall what I've said, always in your exam, just indicate that you know that you're working with vectors, as we are doing a lot of vectors for this exam. So now you have this. But what do you remember from matrix multiplication? So if you distribute in, you can take the scalar outside and you say A x1 transpose. Just remember that matrix multiplication is not commutative. In other words, you cannot write it the other way, since matrix multiplication, as I said, is not commutative. So here I have this term, then the same here. I'm going to distribute the A in. I can take the scalar outside. I have A x2 transpose. But what did we say here? We did choose a vector x in C3 such that it has this property. Hence, I know that this product is 0. The same, I've chosen an x3 in C3 with this property. Hence, I know that this product is 0. Now, what do I know? I know that a scalar times 0 will just be 0. And here, the same, a scalar times 0 will be 0. And there, what have I proven? I have proven that the ZX in C3 has the property that A product X3 transpose is in fact the 0. So as you can see here, the linear combination was extremely important, as well as the two vectors that I've chosen. Do not forget these three very important steps when you prove a linear space over a certain set in the exams. On to the next question. I just want to mention this quickly. We're not going to do the whole question, but you're welcome to try it. So they say, prove that this vector in R3 such that, so we have this property equals 0, is a linear space over R3. Now remember what I said, the three most important steps are I choose a vector v1 with that property, x1 minus y1 minus 5 xz1 0. I let another vector be in R3 with that same property. So what do I do now? Remember I said the third step, very important. You will let v3, another vector in R3, be equal to the linear combination such that v3 has this property. Now just remember here what I do before I start, because remember I want to see now again if this is 0. But very important again, I must write each component here as the linear combination of the other components. Remember that is very important here. Why? Because I want to show that this is 0, and then I will replace x3, I will place y3 and z3. I will get to the stage and I will use these properties again. So you're welcome to pause here, try it yourself first again, and then you can just look at the screen and just familiarize yourself with the way I've done it, and just make sure you understand every step for the exams. Now, on to the next question. Also a popular question for the exams. Find the rank and the dimension of the null space of the given matrix. Now, in my playlist on linear algebra, we did do rank. We also did dimension of null space. Now, remember what rank is. It is the number of non-zero rows in Gauss elimination or in row echelon form. So a mistake students often make, they will just say that rank is the number of non-zero rows. No, it's very important. It's a number of non-zero rows in row echelon form. What is dimension of a space again? It's the number of elements in the bases. So I also did bases in one of the videos in the playlist of linear algebra. Now what are we going to do? We're going to do the dimension of the null space. But I will explain again what null space is just now. Now remember what we're going to do. We are going to do Gauss elimination. But now something that I want you to remember from my previous videos. Remember, you can see here that you have 5 columns. So in other words, you have 5 variables. You have 5 variables. Now remember, how many rows do we have? We have 3 rows. So those are the equations. But since we have more variables than equations, remember a very important thing that's going to happen, we have infinitely many solutions. So we are going to introduce parameters. So what you're going to do here, you're going to do Gauss elimination. Now remember, for Gauss elimination, since we have more variables than equations, we do not include that first entry. We just draw the triangle from the second entry. Now remember in my previous videos what I've done here. I want to make this entry first 0. How do I do that? Remember what I do here. I am going to times the first row by -3. Now I just prefer to write it here so I can see exactly what is happening. So -3 plus 3, 0, 0 plus I, just I, 3I plus 0, 3I, 3 plus 4, 7, -3 plus 1, -2. And then I suggest, remember I said just erase this in exam, otherwise you will confuse the examiner. They will not really understand what you've written there. So that's just for the rough work. And remember, just write here what operation you've done, or what row operation you have done to get this. Now remember, my next step, I'm gonna try and make this a 0. So what I'm gonna do, I'm gonna do row 2 minus 2 row 1. So again, I'm timesing my first row by -2. I have 0, I have 2i, I have 2, -2. Now I'm going to add -2 plus 2 is 0. I have 0 minus 1 is -1. I have 2i plus I, 3i. I have 2 plus 3, 5. -2 plus 0, -2. So what is the last thing I need? I just need to get this bottom row of 0. So how do I get this bottom row 0? I am going to times my row 2. I'm going to times my row 2 by I and then add. So I'm going to times this row by I, so I can get minus I plus I is 0. So just remember, when you times I by I squared is -1. So you get -3 plus 3i. negative 3 plus 3i. Then I times here by I, so 5i plus 7. 5i plus 7, and then I have negative 2i minus 2. So that's now what I got here. Now, often students ask, but why do I not continue here? Remember, if you change this to 0, what's going to happen is that maybe one of these will change back. So the problem here is if we change this to a 0, maybe, or we change this to a 0, one of these will change back to numbers, and we don't want that. So what do we see here? We see that we cannot continue. You can even pause the video and try for yourself. Try to make this maybe a 0, or maybe try to make that a 0. You will see that that does not help. You cannot go any further. So what have we done here? We have done Gauss elimination. So we have row echelon 4. The rank, recall what I said, the number of non-zero rows, very important in Gauss elimination. How many non-zero rows do I have? I have 3. Now, very important, as you will recall, rank plus dimension of null space will always be your number of columns. Now, remember what I said before, we have more variables than equations. We know definitely infinitely many solutions, but we have 3 plus dimension of null space is 5. Hence, my dimension of my null space is 2. So we can also, just recall, we can also say dimension of the null space, dimension of my null space is n number of columns minus r, the rank. Very important. So that means I have 2 parameters. So I have done this in a video before, so I'm not going to do it in this example, since they have just asked us to find the rank and the dimension of the null space. They didn't specifically ask to find the null space. Now remember, the null space is the solution space. So if they had asked us to find the solution space, we would have solved this. What we would have done, we have 2 parameters. So we would have introduced the 2 parameters. We would say, let x5 be t, x4 be s, and then we will solve x3, x2, and x1 in terms of s and t. So that is the rank and dimension of null space. So we have done exam revision on some linear algebra questions, and this is the end of this video.